In this video, I'll be showing you how to solve a system of equation in which one of the equation is quadratic, this one is quadratic, and the other one is linear. The other one is linear. This one is linear. Okay, linear is yellow and is blue one, and the quadratic is a yellow one. So we're going to do it by using the method of substitution, and this is what we do with method of substitution. So we're going to since y equals to the expression and the quadratic, y equals this quantity, the same y also equals this quantity. That means those two quantities are equal to one another. So we're just going to set them equal to each other like this. X minus 1 is the same as x squared plus 2x minus 3. Now we are going to use method for solving quadratic equation to solve this. Let's get rid of the x from both sides, also the 1 from both sides at the same time by doing the opposite. So the left side are going to cancel out. This is cancel out, and you have 0 left, and here will be x squared plus x minus 2, and then we can just go ahead and factor this like this: x minus 1 and then x plus 2 equals 0, in which case s equals 1 or s equals -2. Now this is a system of equations, so we have just found just the x values. We need to find the y values, so we are going to plug in this x value into one of the equations. So I'm going to choose to plug it into the linear one because it's easier. So we'll do y equals, let's plug in the first one, plug in x equals 1. So we're going to do wherever we see x, we're going to replace this x by 1. So it will be 1 minus 1, so y equals 0. In that case, the quantity, the coordinate will be, when x is 1, y is 0. That will be one of the coordinates of intersection. The other one is to set y equals to we're going to set y equals to -2. So we're going to set this x equal to -2, rather this one s equals to -2. So we're going to go ahead and set that to s equals to -2. -2 minus 1, which is going to be -3. So the other coordinate will be when x is -2, y is -3. And now we have the two coordinates. Here is a graph of the same system of equation. Here is a graph right here. So here is the 1, 0, the first point of intersection right here, and the second point of intersection right here, and that corresponds to what we got algebraically. Basically, we're just looking for intersection of a parabola and a line, and it happens to be 2 in this case. Now we go to second example. Here is another example. All right, and I've got started with this example. Again, here is the parabola, and here is the line. Here is the parabola, and here is the line. There is a line, and then so we're just going to set them equal to one another, like I've just done now here. And now we're just going to get x, 0 to one side, and this is how you do it. You subtract x, subtract 4, subtract x, subtract 4, and then you're going to be left with 0 on the left side. That will be 0 on the left side, and the right side will be negative x squared minus 2x minus 1. Now we can just multiply everything through by negative 1 so that there is no leading coefficient of a negative. So it will be 0 equals x squared plus 2x plus 1, which we can factor to be x plus 1, x plus 1. And so equals 0. So x equals 1, negative 1. What that means is that, or s equals negative 1 as well. So it's only one point really, which is s equals negative 1. We can go ahead and plug this the 1 point, that was single point that we have, into the linear equation and see what happens. So we're going to plug it into y equals negative 1 plus 4, y equals 3. So the single point of intersection is at negative 1, 3. So here is a graph for that. Here's a graph. Here is a parabola that's facing down because of the negative. You see the negative down up here? It's facing down, and that is a line. And we found only one solution because the line is tangential to the parabola. It's a tangent line to the parabola at that point. This is another case which is different from the first one that has 2 points of intersection. Here is the last example coming up. Here's the last example. Okay, so we have x squared plus 4 as a parabola, and then this is the line. As usual, we set them equal to one another. And then we are going to solve this equation. First, we will subtract x minus 1, subtract x minus 1, and we will see what happens here. So it's going to cancel. 0 equals x squared minus x plus 3. Alright, so we're going to try to factor this, which cannot be factored, but we can solve by completing the square. So let's try to complete the square. So x squared minus x equals negative 3 by moving the negative 3 to the other side. And if we complete the square for this, we're going to get x squared. A half of 1 is 1/2, and then plus 1/2 squared will be 1/4. So it will be negative x plus 1/4 equals negative 3 plus 1/4. And so the right side becomes negative 11 over 4, negative 11 over 4. And the left side is just going to be squared, like x minus 1/2 squared. Now, if we are going to solve this, we are going to take square root of both sides. So it will be square root of x minus 1/2 squared equals plus minus square root of a negative 11 over 4. Now, x minus 1/2 equals plus minus I square root of 11 over 2. So we know that this is an imaginary situation here, solution. So x equals 1/2 plus minus imaginary square root of 11 over 2. This is an imaginary number. So whenever you end up with an imaginary number like that, that means the line and the parabola don't intersect. So there is no solution, because you end up with an imaginary number, imaginary solution. So here is a graph. We can see that the parabola and the line don't intersect. They don't intersect because of imaginary situation here. So summary. There are 3 possible ways in which your solution can turn out. It can be either no solution, in this case with no solution, or it can be with one solution in this case, or it can be with two solutions like in this case. Okay, I hope this helps. Thanks. Bye. Thanks for watching.